Okay, welcome back. Page 2. Um, Before we get into this, I'm not going to use a calculator, but if you were to use a calculator, say on a multiple choice, to get the log button, the log base button, you're going to do alpha, then window, number 5. So on your test, you'll have to show some steps or some number crunching to show how you solved a logarithm. We don't want to know that you can just punch things in a calculator. But if worse comes to worse on a test, use alpha window 5 and at least get some partial credit. So this number 7 says evaluate the following logarithms. If needed, write an equivalent exponential equation. Try as many as possible without using your calculator. So remember, a logarithm is just another way to write an exponent. So I'm going to write this for letter A, log base 2 of 32. Technically, you don't have to show anything. You should just know the answer is 5. But you could do this. 2 to the what equals 32. That's what you're doing in your head when you find a logarithm. And we know 2 to the 5 is 32. So that answer is 5. Now this one, 27 to the what gives you 3. Well, I know the cube root of 27 is 3, and I write the cube root as an exponent of 1/3. 27 to the 1/3 power does equal 3. 5 to the what is 1 over 625. Well, I know 5 to the 4 is 625. So 5 to the negative 4 is 1 over 625. Remember, a negative exponent doesn't negate the number, it puts it on the other side of the fraction. Letter D, x to the what gives you x. Technically, that's an x to the 1. So that's a 1. I got a yakking dog. Holy cow. Now this guy right here is missing the base. So if there's no base, it's technically a log base 10. 10, 1, 2. So 10 to the what gives you 10,000. Well, 10 to the anything, you just count the number of zeros, and it's 4. This one, log base 9 of what gives you that mess, the 4th root of 81. So the 4th root of 81 is actually 3, because I know 3 to the 4 is 81. So 9 to the what gives you 3? Well, we know the square root of 9 gives us 3. So that exponent is actually a half. I'm going to convert this or rewrite it. Log base 10 of 1 equals. So we would say 10 to the what gives you 1. Well, anything to the 0 gives you a 1. Letter H, ln e to the 7. So I'm going to rewrite this. ln is the same thing as log base e of e to the 7. That's kind of crazy. So e to the what gives you e to the 7. Well, there it is. Our what is 7. So for these, this is how I would show work on my test if I had to show work. Of course, you can show your work and then double check with the calculator. No one is going to say, no, don't check your work. Make sure you check. So now this one, we're technically solving an equation. Oh my Lord, there's a big mess over here. All of this, x to the 3/2 raised to the 4/5 power over the 5th root of x to the 7 equals x to the y. So we're solving for y, but what you're really needing to do, you're going to get a common base. We have to simplify that, okay? So I'm just going to write over here. Here's my fraction bar. To simplify the numerator, that's power to a power. So when you have power to a power, you multiply your exponents. 3/2 times 4/5 is 12 over 10. You can leave 12 over 10. I'm going to simplify it to 6 over 5, but you could leave it 12 over 10. It's fine. And then the denominator, it's in radical form. When you're working with exponents, you want it to all be in exponential form, so you can use laws of exponents. So the fifth root of x to the 7 is the same thing as x to the 7 over 5 equals x to the y. So now, to finish simplifying this left side, we have common bases and we're dividing. So what you do is you subtract. I know the 7/5 is bigger than the 6/5. So if I was simplifying this, what I would do out of habit is do 1 over. So 7/5 minus 6/5 is 1/5 equals x to the y. Now that step is a little bit extra because I think a lot of you know to have common bases, we have to move this to the numerator. So it's x to the negative 1/5 equals x to the y. So negative 1/5 equals y. Let me see if I can get my eraser. So really, this step is not necessary, but if it helps you to process it, then write that step down. Okay, what is this? Number 9, evaluate and show your work. So show your work, yeah, you can put it in the calculator and it will spit out the answer of 1/9. But we have to show our work. So I am going to put this in radical form. Cube root of 27, and then the power is -2. Now, those of you in my class know I hate negative exponents, but I'm just going to leave that for now because I don't feel like putting it over a 1 yet. We know the cube root of 27 is 3. 3 to the -2. Okay, so 3 to the 2 is 9. 3 to the -2 is 1 over 9. So you will have questions like this on your test. This is how you show work. If you say I did it in my head, you're not going to get full credit. Let me clear this. So 10a says graph y equals 3 to the x and its inverse. Please show a table of values for each function. So y equals 3 to the x. Whoopsie. Right here. X, y. I don't have a graphing calculator on my Chromebook at home. So what you would do is you go to y equals on your calculator and do 3 exponent x and then second graph. It is good practice to do some on the negative side of the x and some on the positive side. So I usually go from -2 to 2. And on your answer key, it's got 1/9, 1/3, 139. But if, depending on how you input something, you might see 0.111, 0.333. It means the same thing. It means a really small number. 0, 1, 1, 3, and 2, 9. You must plot points. I don't care how pretty your curve is. In order to get full credit on a quiz or a test, you have to plot points. So I'm going to do 0, 1, 1, 3. And then to do these little bitty ones, just make them look like they're between 0 and 1. Now, oh boy, graphing is tough. All right, that's not so bad. I put arrows and I'm going to label it. Y equals 3 to the x. If you wanted to do the inverse without going back to your calculator, you can just flip the x and y. So you would have 1/9 or 0.111, -2, 1/3, 0.333, -1, 1, 0, 3, 1. Running out of space. Good grief, that's messy. 9, 2. Sorry about that terrible table. So we've got 0.111. Again, just really small points. 1, 0, 3, 1, 7, 8, 9, 2. And remember, both sides get arrows. And then now to label this, you don't write, hey, inverse of y equals 3 to the x. We have to get an equation for that, and that's part B. So show the algebraic process for finding the inverse of y equals 3 to the x. Let's do purple. So first thing we have to do is flip x and y. X equals 3 to the y. Then to get y by itself, you have to put it in logarithmic form. Remember, 3 is the base, y is the exponent, x is the number. Log base number equals exponent. That's all you have to do. Flip the x and y and put it in log form. So now I'm going to take my new equation and label it. Make sure you have points. See these points? Make sure you have points and make sure you label. That way you can get full credit.